Okay, so in this question, it's asking us that Jack has $7.55 of change in his pocket. I think that should say pocket. And then here it says he has 4 more dimes than nickels. That's important. This more is actually telling us that we need to be adding here. And then twice as many quarters as nickels. Well, that twice means that we're actually going to be multiplying it by 2. And they want to know how much of each type of coin does Jack have. So a couple things that you need to know. The first is that when we are doing this, we need to figure out the nickels. So the nickels, I don't know how many nickels there are, so I'm going to just call that n, because that lets me know that n represents the number of nickels. The other thing it's telling me is I need to know about the number of dimes. Now, I don't know about the number of dimes, but it tells me that there are 4 more dimes than nickels. Well, I don't know how many nickels there are, but I can represent that as 4 plus the number of nickels, which is that n. So 4 plus the number of nickels will give me the number of dimes. And then for the quarters, I know that the quarters, it's twice as many, well, times 2, so 2 times the number of nickels represents the number of quarters. Now, the one other thing that you do need to add here is that it's talking about money. So because it's talking about money, I need to represent these expressions also as money, because what this represents is just the number of coins. So I know that a nickel is worth 5 cents, so I can multiply this entire thing by 5 cents. I know that a dime is worth 10 cents, so I can multiply this entire expression by 10 cents. And I know that this quarter is worth 25 cents, so I can multiply this entire expression by quarters. Now, obviously, my handwriting on the computer is not the best, so for that reason, I am going to go ahead and show you a video where you can see me actually writing. So what we have to do is we know that the entire result is $7.55. So I can set this up so that I know that I have 5 cents for every n, that's the nickels, plus 10 cents for each dime. And we know that the dimes are represented by that 4 plus n, plus I know that 25 cents is represented by each quarter, so 25 cents times 2n for the quarters all has to equal $7.55. So now I do the distributive property, and I need to distribute to each thing. So 5 cents times n is 0.5n, plus here I have to distribute to 2 terms, so 10 cents times 4 is 40 cents, plus 10 cents times n is 10 cents n, plus 25 cents times 2n actually gives us 0.50n, equal to $7.55. Then I have to combine my like terms, so I'm going to go ahead and do that. 5 cents plus 10 cents plus 5 cents gives me 65 cents n. This 40 cents didn't match with anything, so we can just bring it down because we didn't have to combine any like terms. All equal to $7.55. If you want, you can draw a line here. You want to get rid of this 40 cents, so we undo addition by subtraction, so that cancels that out, and we're left with 65 cents n is equal to $7.15. And then opposite of times 65 cents is divided by 65 cents, which we do on both sides. This cancels, and we get n equals 11. So going back to our original expression, I now know that there are 11 nickels. So going back to this, I also can then figure out the number of dimes, because 4 plus n represents the number of dimes. Well, if n is 11, 4 plus 11 is 15 dimes. And then 2 times n, well, 2 times 11 gives me 22. And quickly, we can go ahead and we can check our answer. If I were to plug that in, 11 times 5 cents, 15 times 10 cents, and 22 times 25 cents will end up equal $7.55.